Hello and welcome to video 2 on the Intro to Stata on the AU Virtual Applications and Desktop series. In this video, we're going to talk about how to create some basic graphs, run an independent samples t-test, run a correlation, run a simple ordinary least squared linear regression, run an OLS multiple regression, look at help files, and then export the data outside of the AU Virtual Applications and onto the desktop and onto your OneDrive. So let me go ahead and switch over to the virtual application system. And then this is where we left off. So as a recap, we went ahead and we imported data. We ran some descriptive statistics. We recoded. And then we also went ahead and created binning the variables into high, medium, and low groups. So what we're going to do now is we're going to demonstrate how to create a histogram to look at the distribution of a variable, as well as a scatter plot. So a histogram shows you the frequency of the distribution. So I'm going to go ahead and do hist GDPPC. So I'm going to go ahead, highlight, and run 73. And we can see that it's spinning here. That's letting us know that's working. And now we have the density and the distribution of GDPPC scores. There's a couple of things we can do here. Oops. So we can start graph editor and we can customize one by one here. We can add captions. And once you're done, you can go ahead and save that. You can also go ahead and save it as a separate file too. That way you have it for later. What I like to do is I like to use syntax though. So after add a comma, and then I can add the options. I can give it an overall title and a note for the source. So if I run line 75, we can see that, okay, it's also changed the frequency here to our frequency. We have a title, and then we also have a note at the bottom. So this is a little bit cleaner compared to the previous one. We can also do things like run a scatter plot. So if we do a two-way scatter, that's going to go ahead and say, okay, we want a scatter plot of GDPPC and corrupt 2. So GDPPC, since it's the first variable here, that's going to be on our y-axis. Corrupt 2, our reverse coded perceived corruption score, is going to be on the x-axis. So now we can see the scatter plot. Now, if we were to imagine drawing a line of best fit there, it'd probably be right around there. What we can do then too is we can actually add that line of best fit by adding some additional commands. So lfit in parentheses, that's saying give me the line of best fit. We have a comma for additional options. We're giving it an overall title and a note on where we got the data set. So when I highlight and run line 82, we have that line of best fit. So that's our fitted values. That's our regression line. We have our title, our GDPPC here, and corrupt 2. I can go ahead if I wanted to. I can, let's see. Oops. I can click on Start Graph Editor. I can double click into this, and I can change this to perceived corruption. And so we can also change the margins. Gives you a lot of different options here. So I'm going to go ahead and click on title here, and I'll put gross domestic product per capita. There we go. I'm going to go ahead and save this. I'm just going to save this as my awesome scatter plot. It's going to save it as a GPH file, which can be read by Stata. So I can go ahead and save it there, but I can also go to File, Save As, and I can go ahead and put it as a JPEG. Again, when I'm doing that, we actually have the graph save and graph export commands that we can go ahead and put that into our syntax if we wanted to. So if I click over here, we have the .graph file for Stata we can read, and we also have a JPEG version. Now we need to transfer that over because it's still processing right now, it looks like. So what I'm going to do now is I'm going to go ahead and move that there. And let's scroll back down. So let's go ahead and just rerun this scatter plot because I want to mention a couple of things. Oops, I do not want to use the view option. Okay, so looking at this, suppose you're curious about the relationship between GDP per capita and the amount of perceived corruption. So this will help us visualize this relationship. So it looks like as countries are getting more and more corrupt, the gross domestic product per capita is lower. So again, we can't infer causation from this, but we can see that there is a relationship between corruption and GDP/PC, visually at least. Later on, we're going to want to then run this as a test. See, okay, is there a significant relationship? We can also create bar graphs by using graph, state the type of bar type here, mean. So we want the mean of GDP/PC over corrupt CADIC. What that's going to do is it's going to go ahead and give us for all three categories of corrupt CADIC, the mean for each one. We're going to graph those as a bar chart. So I'm going to go ahead and highlight and run this. And there is the mean scores of each of our corruption categorized. So for low, the average was about 32. This looks like maybe about a 12 medium, and that's maybe like a 2 or 3 for high. Now, if we're interested in looking at that visual, say, okay, is there a significant difference between this? Like, let's say we want to figure out, okay, is there a difference between medium and high here, R2 or R3? We can actually test this by using an independent samples t-test. So we're now in the bivariate analysis. So the t-test is the most basic way to compare two groups based on their mean scores of a single variable. So while we provided corruption CADIC into 3 variables, we can only compare 2 at a time. So we're going to compare groups 2 and 3, which is our medium and our high corruption categories. So I'm saying t-test GDP/PC if, and because we have 3 levels, we need to specify. By doing that, we're going to say in list, state our variable, and then what are the specific values? So I'm comparing medium and high, and do a comma by corrupt CADIC. I'm gonna go ahead and run this. Actually, I'm gonna go ahead and, just because the way it prints out, I'm gonna make that bigger. I'm gonna go back here and I'm gonna rerun it. And now we have our independent samples t-test, or our 2-sample t-test with equal variances. So we're assuming the variability in the medium group is not statistically significantly different than the variability of the high group. So we can see, okay, what's the means? It's just our descriptive information. This is our difference. So if we subtracted from medium the high score, that's our difference. That's going to give us, we also have our standard errors. So the mean difference between this, the null hypothesis that the difference is 0. So the t-statistic of 10 and 126 degrees of freedom, we can see, so it kind of based on this, that if it's not equal to 0, that's our alternative, that is statistically significant. That's kind of giving it as a two-tailed test because we're not sure where the difference is. We're just saying that it's not equal to 0. So this is statistically significant. Looking back, that if we looked at our scatter plot again, so I'm gonna go ahead and rerun line 82. If we're interested, is this relationship, this correlation between this, is this statistically significant? We can then run a core GDP/PC in corrupt 2. Let me go ahead and move that. And we can see, looking at this, that the correlation between that is a 0.89. So that is a strong negative association, a correlation. But we don't have a statistical significance value with this. I do also go ahead and run this. So it's just saying PW core. That's going to give us a statistical significance value. So our p-value, that is less than 0.050, so that is statistically significant. But for this and for our t-test, I do want to mention, though, that p-values do not provide any information about reproducibility, the probability of getting the results by random chance, or the size of the effect. This is kind of just given that we sampled from population where the null was true, we have a low probability of getting this. The 0.050 is a cutoff point that we're deciding if it's below that cutoff, then we're saying it's statistically significantly different from zero, so we're going to reject the null. It's not going to tell us how large the effect size is, though. So for this correlation, given that it's a negative 0.89, we could say that's a strong one, given that it's bounded between 1 being a perfect positive relationship, a 0 being a non-relationship or no relationship, and a negative 1 being a perfect inverse relationship or negative relationship there. So we do see this 2 by 2 matrix. And we also have our statistical significance. Now, this is just the variable with itself, so that should by default be 1, since this is standardized. Next, what we can also do is we can also run a simple regression to understand the relationship. So as we're increasing corruption scores, what that's doing to GDPPC, looking at that line of best fit. We can also look at it in terms of an equation of rise over run. So I'm going to go ahead and run 102. That's going to go ahead and run a simple OLS regression. So we have our sums of squares, our degrees of freedom, and our mean squares. We have our totals. We're going to get our AF ratio statistic. And our omnibus regression is saying that overall there is a relation. We're able to account for a significant portion of variability, which is our R squared. We were able to account for 79% of the variability in GDPPC by knowing the perceived corruption levels. So that's 79%, that's a lot. But more importantly, we can look at the coefficient. So our intercept, knowing nothing about corruption score, where's our best guess, and kind of where is that intercept when we have that line. And then as we know more and more about the corruption, we can say, okay, as we increase corruption scores, we're seeing a reduction in GDPPC. So that's the rise over run. For each unit increase in corruption 2, GDPPC is going down by 4,761.49. This is statistically significant. We can also see that we cannot fit 0 within our 95% confidence interval. We can also extend this by adding an additional variable. Like let's say we wanted to look at literacy. So we can say regress, which is short for regression, GDPPC, that's our outcome variable, our first independent variable, and then we can add another independent variable. So now we're talking about multiple linear regression. I'm going to go ahead and run that. And now we can see, okay, we're accounting for a little bit less. We've lost some cases here because of our missingness. We went from 151 to 118. And this is the dangers of missing data because it will use list-wise deletion. So now we might not be able to generalize because now we're actually looking at a subset that's actually less than half of our entire data set. So I believe we have about 217 cases. We can actually find that out specifically by looking at our variables here. Yeah, 217 observations. So this is a subset now. So we want to be really cautious with our interpretations. Our F statistic is 122. The probability, or our overall p-value for our omnibus regression, is statistically significant. We're able to account for 68% of the variability. And when we look at the adjusted R squared, which is essentially saying because we have additional predictors, it's removing some of the potential bias there. We can see corruption 2 is statistically significant, but when we hold literacy constant, for each unit increase in corruption, there's a reduction in 3,510 for GDPPC. When we hold corruption 2 constant, we can see that with literacy going up, there is that increase in GDPPC, and it is statistically significant. Let's see. I'm going to go ahead and skip this a little bit because I want to go back and mention help. So when you're first learning Stata, all of the Stata manuals can be found. So let me go ahead and pull this up. So Stata let's say we're using Stata 16 for now. They've recently released Stata 17. But let's say we wanted to get the manual. We can go ahead and go to Stata's website. They have the documentations. We can actually just download the entire manual, and this has all of the information that we might be interested in. So if we're interested in, like, let's say we were doing multi-level mixed effects, I can pull up that specific one as well. So they've gone ahead and they've created a really nice way of getting all this information to you. It's all these PDFs are completely free. What we can also do though is I can also type in help regress, and that's going to pull up the embedded help files. This tells us all of the different options. So if I wanted to use robust standard errors, let's say I wanted the beta weights or the standardized coefficients there, what I could do is I can go back to my syntax. I can go ahead and do a comma beta. I'm going to go ahead and highlight this. And now we get our beta coefficients. So that's our for each standard deviation increase in corruption. There's a 1.69 standard deviation decrease in GDPPC. So different disciplines might use beta weights rather than the raw metrics instead. So if you're ever interested in, so anytime you have a function that's this blue, we can go ahead and just do like help sum. And I can pull up the summarize, and that gives us all the options that we have there too. So it's a really, really quick way of learning the different commands that are available to you within this. So a couple of things we can do. So if you press the page up button, on your computer, or page down, that's going to go ahead and you can scroll through your history and pull up some previous commands that were typed in the command window. If you're using syntax, that's not going to be as helpful though. So we already talked about the variable name. So if you wanted to go ahead and let's say I wanted to, in the command window sum, I can go ahead and let's say I wanted some hunger. If I click next to this, the download icon there, it's going to go ahead and put hunger there. So it's a really quick shortcut. If let's say it's taking a long time, we saw that spinning wheel here, you can press either Q on your keyboard, or there's this red X button that will stop it. Again, the properties that will tell you more about your data set and in the individual variables there. Now, you can also go ahead and you can use user installed macros. These are called AU files, which has additional features that are not embedded within Stata itself, but they're kind of like added features that you can use. So I'm going to go ahead and install something called asdoc. And what this is going to do is then we can actually, when you do asdoc core, I can actually get a correlational matrix. So that's our correlations. And let me go ahead and click on this. On our desktop, it went ahead. Okay, so it's still doing that. So we have within our Word doc, we actually created and exported the correlational matrix into Word. You can ignore that error. If you want to sign with your credentials, you can also do that. But we have that my file there, and we'll export that after. You can go ahead and also do specific descriptive statistics. We'll use asdoc, tab stat, and then comma stat. And I want the number of observations, the mean, median, and standard error of the mean. I can go ahead and run that. And now I have that information in a file called myfile.doc. So it's appended it. So because it already exists, we now we'll have another table on there too. Let's say I wanted to save my data set, which is always good to have it. I'm going to go ahead and save it as a backup. So I'm saying save. Backup is going to be the name of the file.dta. And if we already have it in there, it's going to go ahead and replace. So we have a backup file now. So if I go ahead and if I close, let me save this. If I close out of Stata, so we have our intro, we have our data files, we have our plot, we have that. We have this, and we also have our Stata tour. If I double click into there, this is showing us each and everything we ran, which is a really, really helpful way of getting this information. Now what I'm going to do is I'm going to go ahead and I'm going to create a new folder and say workshop Stata completed files. I'll go ahead and move all of these into this. I'm going to pull back up my OneDrive. Let me go ahead and we don't need that. We don't need that. I'm going to drag and drop this into it. And now that we see it's uploading, let me just double click into there. Okay. So now what I'm going to do is I'm going to go ahead and close out of this. I'm going to go to File. I'm going to sign out of the virtual desktop. And we're just going to give this a couple of seconds. Okay. And let me go ahead and close out of that. And I'm going to go back to my OneDrive. There's our completed files. I'm going to go ahead and download it. And because there's multiple files in there, because it's a zip file, I'm going to go ahead and extract. Let me get rid of that. And so we have our JPEG file that we created before. We have our Word doc that we export some of the results to. So there was our correlation. And there was our summary statistics. You can also do things like the different statistical analyses, correlation test, and regression as well. And now we have all those files. I hope this video was helpful in getting you started with Stata.